from 1 to infinity of a sub n equals a sub 1 minus a sub 2 plus a sub 3 minus a sub 4, and so on. And usually these series include the term negative 1 to the n or negative 1 to the n plus 1, because that's what makes it alternating. And if a sub n plus 1 is less than a sub n, which means the series is decreasing for all n, and the limit as n approaches infinity of the absolute value of a sub n equals 0, then the series will converge by the alternating series test. And you have to note that this test is only for convergence, so series don't diverge by the alternating series test.
All right, in the first example, we have the series as n goes from 1 to infinity of negative 1 to the n plus 1 times 3 over n plus 4. So we start off by listing the first few terms. So we have 3 over 5 minus 3 over 6 plus 3 over 7 minus 3 over 8. And that shows that the terms are decreasing. And then we take the limit of the absolute value of the a sub n, which is negative 1 to the n plus 1 times 3 over n plus 4. And the absolute value eliminates the negative 1 to the n plus 1 since it's just determining the sign. So you take the limit as n approaches infinity of 3 over n plus 4, which gives you 3 over infinity, which equals 0. And since the terms are decreasing and the limit equals 0, the series will converge by the alternating series test.
So example 2, we have the sum as n goes from 1 to infinity of negative 1 to the n times n over ln of 2n. So first, I decided to take the limit of the series. So the limit is n approaches infinity of the absolute value of negative 1 to the n times n over ln of 2n. And so when you do the absolute value, that cancels out the negative 1 to the n term, and you're left with n over ln of 2n. Now, when you plug in infinity, you get infinity over infinity, which is indeterminate form. So we use L'Hopital's rule to find the limit. And so when we did that, you get limit as n approaches infinity of n, and that equals infinity. So although this is an alternating series test, the limit did not go to 0, and so the alternating series test is only a test for convergence. So this series diverges by the nth term test, not by the alternating series test.
And the third example is a series that n goes from 1 to infinity of cosine of pi n over n squared minus 5. So first, you take the limit as n approaches infinity of the absolute value of the a sub n, and so that in the cosine pi n, that acts as the alternating portion instead of the typical negative 1 to the n. So when you take the absolute value, you get the limit as n approaches infinity of 1 over n squared plus 5, which gives you 1 over infinity, which equals 0. And as opposed to plugging in terms, you can also take the derivative to determine decreasing terms. So when you take the derivative of 1 over n squared minus 5, you get the negative n squared minus 5 to the negative 2 times 2n. And since the derivative is negative, you know that the function will be decreasing the entire time. So therefore, the series converges by the alternating test since the terms are decreasing and the limit equals 0.
What's that over there?
Is that a telescope?
It's a telescoping series test. Now we have the telescoping series test. A telescoping series is a series whose partial sums eventually only have a fixed number of terms after cancellation. The series will converge to the sum of the uncancelled term and the nth term as n approaches infinity. So our first example is a series from 1 to infinity of 1 over n minus 1 over n plus 1. So the first thing you want to do is that you want to plug in numbers, and you end up seeing that most of them cancel out except the first one, which is just 1. So the sum, as I said in the explanation, is 1 minus 1 over n plus 1, and then you take the limit of that, and you end up getting 1. So the series from 1 to infinity of 1 over n minus 1 over n plus 1 converges to 1 by the telescoping series test.
So the second example is another example of partial fraction decomposition mixed with the telescoping series test. So in this case, we have the series from n equals 1 to infinity of 6 over n times n plus 3. So we're going to use partial fraction decomposition to break it down into something that we can actually find the sum of using the telescoping series test. So we have 6 over n times n plus 3 equals a over n plus b over n plus 3. So by using partial fraction decomposition, we find out that a equals 2 and b equals negative 2. So from that, we can set up a new series where we can plug in a and b for the different numerators of the different fractions. So we have the series from 1 to infinity of 2 over n minus 2 over n plus 3. So plugging in terms, we find out that most of the terms cancel out, but not all of them. So this is a case where we have an initial term that isn't just 1. In this case, we have 2 over 1 plus 2 over 2 plus 2 over 3. So that would be all of our initial terms. So our initial terms add up to 11 over 3. So the sum is the first term minus the nth term. So from there, we're going to take the limit. So we have the limit as n approaches infinity of 11 over 3 minus 2 over n plus 3, which is the nth term. So from there, the 2 over n plus 3, that limit when n approaches infinity equals 0. So we're just left with 11 over 3. So using the telescoping series test, we find out that the series converges to 11 over 3.
You just like throw it up and like,
Oh no. Oh, whoa. Okay. Cool.
I can't tell if you can see us or not.
We'll have to do a couple of takes.
I'm definitely kidding. Wait,
So we'll count to 3.
And then we're gonna pop out and say calculus.
Yeah, 1, 2, 3.
What's that over there?
Yeah.
okay, so now we have a telescoping series test. So telescoping, what? Oh.
Cause oh my god, I totally just messed up. I'm so bad.
You
sort of did it.
Yes, you did it. You did it.
Sam, you sing a guitar lesson.
Cannot play guitar.
Let's see.
I can't.
Amazing.
Guitars are like, it sounds good even if you're like, don't even know.
Yeah, we're just like.
Yes. Wow, Ilona's a musician. Congratulations.
Wait, how is it?
Whoa.
I totally forgot. Is that Liv?
Whoa. Look at, you need to show the chicken wing.
Wow. I'm so sorry. That was
Africa and America.
It's Australia.
And I love CALC.
Yes.
Wait.
Wow.